All right, we are going to continue our work on graphing linear functions. I just want to do a quick review of what we talked about last class. Remember, we were graphing functions in what we called slope-intercept form. What we mean by that is it's written in such a way that we can quickly identify the slope of our graph. That's the coefficient of x. And we can identify the y-intercept. That's the constant here. Just by looking at the equation. So if I wanted to graph something in the form y equals negative 2x plus 6, I can start by plotting the y-intercept. So as we said, I can see this equation is going to cross the y-axis at 6. So I'll start by going to the y-axis, plotting a point at positive 6, and then I can see my slope is negative 2. And we said it always helps to think of the slope as being a fraction, so I'm going to think of it as negative 2 over 1. And then from my intercept, I can now move down 2 spaces and right 1 space for a slope of negative 2. And I can really do that several times if I can fit them onto my graph. And I have successfully graphed the function negative 2x plus 6. I'll draw my line across the graph, add some arrows to indicate that this graph is going to continue forever in both directions. So that's what we were doing last time, but we had some good questions last class when we encountered equations that look more like this. Okay, so it's no longer written in slope-intercept form, right? I don't have the y isolated by itself on one side of the equation. It's written in what we refer to as standard form, with x and y together on one side of the equation, and you'll notice both of the coefficients of x and y are both whole numbers. We don't have any fractions in this equation. So we've got a couple options when we want to graph something like this. One of them, and it works really pretty well when our coefficient on y is 1, which it would be in this case. Remember, if we don't see a number there, it really means the coefficient is 1. I can try and isolate that variable by itself. It's like solving a literal equation. I can try and get the y by itself on one side of the equation. And I could do that in this instance by just getting rid of the 2x, right? I could subtract 2x from both sides. And so my new equation, since my 2x's would cancel, would look like this. Y is equal to negative 2x plus 6. I just subtracted 2x from both sides and I rewrote it. And you'll notice that's the equation that we had just graphed. So really, this is the same equation. So that's one option when you're trying to graph something that's not in slope-intercept form, is you can always rewrite it so that it is. But we're going to look at a different method today. We're going to use the intercepts to graph this. So we have a little bit of experience with that because we had been using the y-intercept to graph. Now we're going to use the y-intercept and the x-intercept. Remember that when we're graphing things, anything that lands on the x-axis is going to have a y-coordinate of 0. And anything that lands on the y-axis is going to have an x-coordinate of 0. So anything on the x-axis is going to be the x-coordinate and then a 0. Anything on the y-axis will have a 0 and then the y-coordinate. So when I'm plugging numbers into this equation, if I'm looking to find the x-intercept, I know the y value would have to be 0. So if I were to substitute y or 0 in for y into this particular equation, it would be kind of like the y wasn't there, right? It's 0. So I'm really just solving a one-step equation here. I just need to solve the equation 2x equals 6. And I can do that by dividing both sides by 2. And I'll get my solution, x is equal to 3. So I've just found the x-intercept of this equation, right? X is going to be 3. We said we only need 2 points to graph a linear equation, and I've just found one of them. I found my x-intercept. So I'm going to put a dot on the x-axis at 3. And now I'm going to find the y-intercept. So in this case, I want to put 0 in for x. Well, 2 times 0 would be 0. So again, it's kind of like the x term is not even there. You'll notice that anytime I substitute 0 for x or 0 for y, it really has the effect of just making that term disappear. And now I'm left to solve the equation y equals 6. Well, there's not really much to do. it's really already solved, right? Y is equal to 6. So I now have just found the y-intercept. And again, I just need those 2 points to graph it. So now I can draw my line through those 2 points. Again, put my arrows at both ends. And we've just solved or graphed the equation 2x plus y equals 6. And you'll remember me saying this was really the same equation, right? So we ended up with the same graph. But that's the method we're going to be looking at today, is using the intercept. So let's do another one of those. Let's say I want to graph the equation 3x minus 4y equals 12. So I'm going to start again by trying to find the x-intercept, which means I'm going to substitute 0 for y. So we're using what we kind of refer to as the cover-up method. I'm really going to pretend that 4y is not there. So you can take your finger, your pencil, cover it up. In this case, I'm just going to erase it temporarily. Let's pretend the 4y is not there because I put 0 in for y, which leaves me to solve the equation 3x equals 12. And to solve that, I'm just going to divide both sides by 3. And I'll find my x-intercept to be x equals 4. And remember, that's really an ordered pair. It's the ordered pair for 0. Right? It's going to cross the x-axis at 4, which means the y-coordinate would be 0. And now let's go back and solve for y. So I'm going to try and find the y-intercept, which means I'm going to substitute in 0 for x. Again, it has the effect of kind of making that x term disappear. So now I just have to solve the equation negative 4y equals 12. Again, I'm going to divide both sides by negative 4, and I'll get y is equal to negative 3. So now I've just found my y-intercept. My y-intercept will be negative 3, or this is really the ordered pair 0, negative 3. So now I'll go to my graph. I'll go to the x-axis. I know it's going to cross the x-axis at 4, so I'll put a dot there. I know it's going to cross the y-axis at negative 3. I'll put a dot there. There are the 2 points I need to graph my line. Draw my line through those 2 points across my graph. Straighten it out a little. Draw my arrows, and I've just graphed the equation 3x minus 4y is equal to 12 by using the intercepts. And we'll look at one more example. Let's graph 2x plus 4y equals negative 8. Again, using the cover-up method, I'm going to find the x-intercept, which means just ignore the y temporarily. Right, solve the equation 2x is equal to negative 8. It's a pretty simple one-step equation. Just divide by 2. Negative 8 divided by 2 would give me negative 4. So I know it's going to cross the x-axis at negative 4. Now let's find the the y-intercept. So now I'm going to substitute 0 in for x. So it's kind of like the x term is not there. Again, I'm left with solving the equation 4y equals negative 8. So if I divide both sides by 4, I will get y is equal to negative 2. So it's going to cross the y-axis at negative 2. There are my 2 points. Draw my line through them. Add my arrows, and I've just graphed the equation 2x plus 4y is equal to negative 8.